Today's video, we are on page 307 and we are going to work on the extra practice problems for solving equations. So I'm going to go through the even number problems on this page, and then your homework is to complete the odd number problems on your own. So let's start off by looking at number 14. We have 9g minus 14 equals 2g. So the first thing we need to notice is that we have variables on both sides of the equation. So I'm going to draw a line right down the equal sign just to help me remember what happens on one side must happen to the other side of the equation. Now, for this example that they wrote out, we took the 9g and we're moving it over to the 2g. The reason they did that is that way g's were on one side of the equation and your constants were on the other side. But you could have moved the 2g if you wanted to. You would just have a couple extra steps. So since this is a positive 9g, we're going to subtract 9g from both sides. We have 2g minus 9g gives you a negative 7g. This was a positive 2 and a negative 9, so you subtract the difference of the numbers. So we have negative 7g equals, you bring down the negative 14. Now we need to get g by itself. This is multiplying by negative 7, so I'm going to do the inverse operation, which is dividing by negative 7. Properties of equality tell us whatever we do to one side, we have to do the other. So if I divide by negative 7 on one side, I have to divide by negative 7 on the left-hand side. So I have negative 14 divided by negative 7 gives me a positive 2. So g equals positive 2. So let's go on to number 16. I'm going to start by drawing my line across the equal sign, and I have 2.5h minus 15 equals 4h. I still have two variables, one on the left and one on the right, but I need to get them together. So I am going to move the 2.5h over here with the 4h, so the h's are all by itself. I'm going to subtract 2.5h from both sides. Now, when we do that, we need to make sure that we are lining up the decimals. So I'm going to rewrite 4 as 4.0h so that I have the decimals lined up correctly because we are using subtraction. When you add or subtract, you have to make sure the decimals are lined up. I'm going to bring down my minus 15 equals, I'm going to have to borrow from the 4 here, changing that to a 3. So that's 10 minus 5 is going to be 5. 3 minus 1 is a 1. Bring down the decimal. So now I have negative 15 equals 1.5h. Again, my goal is to get h by itself. This is multiplying 1.5 times h, so I'm going to divide, do the inverse operation. Properties of equality tell me to move it to the other side. Whatever you do to one side, you have to do the other. So we are dividing negative 15 divided by 1.5, which gives us negative 10 equals h. All right, let's go ahead to the next problem, number 18. Number 18 is a word problem. So it says, Will averages 18 points per game and is the all-time scoring leader on his team with 483 points. Tom averages 21 points a game and is currently second on the all-star scorer list with 462 points. If both players continue to play at the same rate, how many more games will it take until Tom and Will have scored the same number of total points? So we're talking about two different people. We have Will and we have Tom. So those are going to be the two sides of your equation. So I'm going to write my equal sign, and I'm going to put Will on the left, and I'm going to put Tom on the right, and we want them to be the same, which means we want them to be equal. So if I look at the sentence that talks about Will, he averages 18 points a game and is the leader with already 483 points. So 18 average per game. So X represents games, plus the 483 points he already has. So that's Will. He already has 483 points, plus the 18 points he gets per game. Now we go to Tom. Tom averages 21 points per game and currently has 462 points. So I'm going to say 21 points average per game, which is X, plus the 462 points that he already has. Now I have an equation that is equal, so I'm going to draw my line down the equal sign, and I need to get my variables on the same side. So with this, it doesn't really matter if you move the variable to the left or if you move the variable to the right, but because 21 is a larger number than 18, I'm going to move 18 over to the side with Tom. So this is a positive 18x, so I'm going to subtract 18x from both sides. So I'm going to borrow from the 1, from the 2. So 11 minus 8 is going to be 3x. And I'm going to bring down my 483, bring down my 462. Now I need to get my constants, or the total number already scored, and get them on the same side. So I'm going to subtract 462 from both sides. And that's going to give me, I'm going to move over here because I'm out of space. 3 minus 2 is a 1. 8 minus 6 is a 2. 4 minus 4 is 0. So that's 21 equals 3x. Then I'm going to divide by 3 on both sides, and I get 7 equals x. So that means after 7 games, Tom and Will have the same number of points. Moving on to number 20. Now this one can look very complicated because of the shapes, but don't let it fool you. The directions say write an equation to find the value of x so that each pair of polygons has the same perimeter. Same perimeter means we're going to make them equal. Now, first you need to remember what perimeter means. Perimeter means we're going to add up all the sides. So the triangle has to be equal to the rectangle. So I'm going to put my equal sign. And on this side is going to be the triangle. I'm going to add up x plus 4 plus x plus 5 plus x plus 2. So those are the 3 sides of the triangle. On this side, we know it's a rectangle and opposite sides are parallel. So that means those are the same. So I'm going to have x plus 3 plus x plus 1, and then we do it again for the other 2 sides. X plus 3 plus x plus 1. Now I'm going to draw my line, and I'm going to find my like terms. So I have 1x on the right, 2 x's, 3 x's. So that's 3x. I have 4 plus 5, which is 9, plus 2 is 11. Now I'm going to look at the right-hand side. I have 1x, 2x, 3x, 4x. And then I'm going to say 3 plus 1 is 4, plus 3 is 7, plus 1 is 8. So now it's a little bit simpler. We need to get the variables on the same side. This is a 3x, this is a 4x, so I'm going to move the smaller number over to the bigger number. So I'm going to subtract 3x, giving me a 1x, or just x. Bring down the plus 8, bring down the 11. Now I'm going to subtract 8 from both sides. Move this out of the way. And that gives me x equal to 11 minus 8, which is 3. So that means that x equals 3. All right, flip to the other side. And just a couple more. Here's another example, just like we did of number 22. Find the value of x so that the polygon has the same perimeter. I'm going to help you set this one up, but then you can solve it. So we have to make the triangle equal to the hexagon. Sorry. So there is x plus 4 plus x plus 4 plus x plus 1 for the triangle. Now we have 1, 2, 3, 4, 5, 6 of the same size. So you could use parentheses for this one and say 6 times 2x, because that represents all 6 sides and they're the exact same measure. So you can do that when they're the same expression. Now we use the distributive property and we get 12x equals, combining your like terms, we have 3 x's plus 4 plus 4 plus 1 is 9. Now we're going to get x's on the same side, so I'm going to subtract 3x so that I get 9 equals 9x. Divide by 9, so x equals 1. Okay, go ahead and solve all of the odd problems on page 307 and 308.